friends, so we've spent a couple days now in the world of probability distributions, which at the end of the day, if we want to make it as simple as possible, are t-tables that outline the potential values of any given experiment and the likelihoods of those things happening. And we've looked at a number of examples of them. We're going to look at more today. And what's nice is they're super ubiquitous in the world of probability and statistics, in that it's a really efficient way of organizing data into a table, just like it was back in the beginning of this course when we had tables of data and we found averages and standard deviations and stuff like that. You can do the same thing with probability distributions in the same ways. I just want to make sure that you know what that looks like and how it behaves. So I figured it'd be kind of a fun thing to look at. Let's roll a four-sided die. This is kind of a silly example in the realm of life, but the math that we'll learn with rolling this four-sided die actually will translate beautifully to things like the lottery and your insurance. So we'll start here and go there. In particular, I don't just want to roll a four-sided die because that's kind of boring. With a four-sided die, you've got four sides, and there's a 25% chance of rolling any side. I want to get a little bit more interesting. I want to roll this die a number of times until I end up getting a side to repeat itself. So we're going to roll this die until we get one of the sides to show up more than one time. Not in a row, just a number of times. Let me show you some examples of what I'm talking about. Okay, everybody. So the first thing you have to do is you have to realize kind of how this die falls. So since it's a tetrahedron, a point sticks up, and that point tells you which number it is. So for example, I just rolled a 2 because the point facing up is all 2s. So I'm just gonna go ahead and I'm gonna roll to demonstrate this experiment, which is roll until you get a repeat. So I'm gonna count that as my first roll. So I rolled once and got a 2. I just got a 4. I don't know if you can see that or not. I'll try to pick it up. These are hard to pick up. Got a 4. So I got a 2 and a 4. I'm looking for a repeat. And I just got it. There's another 4. So that took 3 rolls. I went 2, then 4, then 4. Okay, let's do it again. That would count as a roll, as 3 different rolls. All right, so this time I got a 3. So this is a brand new experiment. I got a 3. Let's roll again. I got a 2. A little hard to see. There it is. Got a 2. Let's roll again. I got a 2 again. So I got a 3 and then a 2 and a 2. That also took 3 rolls. Let's do another one just to make sure we drive this point home. I got a 4 that time. Okay. I got a 1 that time. I got a 2 that time. I'm not done yet. I got a 4, a 1, then a 2. And I just got a 1. There we go. I got my repeat. 4, 1, 2, 1. That took 4 rolls. So hopefully you can see kind of what the experiment's all about. Okay, so now you know how a four-sided die works, and you understand the experiment. So what we're looking for is the total number of rolls it takes until we see a repeat. Now hopefully, we saw 3 rolls, then we saw 3 rolls, then we saw 4 rolls. But that's not the only possibilities for a number of rolls it takes. For example, let's let X be the number of rolls until we get a repeat. Now clearly, we didn't see any of the smallest possible number you could get there. Because it's possible, it didn't happen with our examples, it's possible to roll a number, say 3, then pick up the die and roll that exact same number again. So the smallest number it would possibly take would be 2. Now we did see 3, we also saw 4, and it's possible to see 5. Because you could roll each of the sides once and have, like, for example, 4, 1, 2, 3. And then whatever you roll next is going to repeat something you already saw. So those, my dear friends, are all the possible values of this random variable of the experiment. Roll until you get a repeated face. Now the fun part, in my humble opinion, is figuring out the probabilities that go with this. We'll do that in the next video.